Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hello, everybody. Thank you for joining us on a brand new episode. This is going to be an episode about best practices and guidelines with wireless networks and how we deploy Wi-Fi networks. I want to introduce Francois here. He's traveling today. Hello, Francois.
Hey, Roel. How are you?
I'm good. We actually have our times swapped this time. So usually I'm the early bird. Now you are.
Yeah. And I don't know how you do it. Recording early in the morning is tough.
Well, this time I get to sleep in and you're already starting your day. It's already evening here for me, so we have quite the distance, so hopefully there isn't too bad of a delay here while we talk. But we want to go into this question of why don't we have one industry set of best practices or guidelines when it comes to Wi-Fi design and configuration, deployment. So we're going to talk about that. And this is really going to be from the perspective of me and Francois and how we've dealt with networks in the past and how we've done wireless networks in the past. So we won't necessarily say these are the hard set best practices, but we want to talk about best practices from our experience. Anything you want to add to that, Francois?
Yeah, no, I just want to say that, this we got inspired to do this episode because of the Wireless Broadband Alliance releasing a deployment guideline document on Wi-Fi 6 that was pretty good. And then we just wanted to, share some of that content with you guys. And then if we just expand it to, the broader subject of guidelines and best practices, we just wanted to, I guess, talk about that a little bit.
Yeah, because we'll link out to the document in the show notes. But that document I thought was really well done. It was well written. It was technical, but not too technical, and it made a lot of sense. Do you agree, Francois? Yeah,
and it feels like they go straight to the point as well. Mm-hmm. So that, they don't fluff around with, I guess, more marketing stuff. And then they tell you exactly technically why it could be an advantage or why this specific feature will not really apply in some situations and so on. So when you read the document, it's really good because it speaks to us engineers, and you even learn some stuff you didn't know about Wi-Fi 6 and the benefits, some of the benefits of Wi-Fi 6 in some scenarios, and you kind of understand a little bit understand the motive behind the new technology, right? It's not only for wireless, for enterprise Wi-Fi network, and so you kind of get a different perspective, I guess, on the overall Wi-Fi 6 technology. I guess at least that was my feeling reading the document.
Yeah, it was specifically done for Wi-Fi 6. They do reference previous wireless generations, but there is a separate document that is just generally Wi-Fi, but this one is specific to Wi-Fi 6. And the way I want to approach this is, why has it taken this long to come up with a best practice or a set of guidelines? I know we see these types of documents from specific vendors, for example. Like I know I see this from Cisco. You will see this from Aruba. But that is very specific to their equipment, where the Wireless Broadband Alliance, this is a vendor neutral alliance, but it is composed of other vendors as well. But they've come together. It seems like the very technical guys have came together to create this document and share it out with everyone in the world.
Well, I think, to answer your question, it's very challenging to come up with, best practices that would fit everyone, especially in Wi-Fi.
Right. And that's because every environment is very different. You could tune things differently. A best practice may not fit in that environment, for example, like a stadium best practice is not necessarily a corporate office best practice. So it really depends on the environment you are working in when it comes to these best practices.
Yeah, it depends on your needs as well. What type of client devices will you have to support? What type of application will you have to support? What type of density of client you have to support? So yeah, it depends on a whole bunch of different things. And that's why Wi-Fi. I guess Wi-Fi design is not that simple, because it's going to be different every time.
Right. But when we talk about Wi-Fi design, I believe there are a set of best practices that we follow as designers, and there are a set of guidelines that we follow as designers or implementers of Wi-Fi networks. Because when it comes to best practices, the question really is, whose best practice is that going to be, right? And like I said before, maybe you're following a vendor's specific best practice, but sometimes you tend to go off of that script, right? You tend to go off of that best practice and maybe adjust a few things because there's something about that environment that just might not work in particular within that best practice. Now, those best practices that a vendor creates, that is based on what they've done in their lab, or maybe what they've done with their previous customers, the big customers that they've worked with. And so that's how they generate those best practices, and also all the other information that they gather with like TAC cases and reaching out to other customers to build this documentation. But this is the first time we've seen from any company or organization where we see this Wi-Fi 6 deployment guideline. And so I think that's pretty interesting, especially since there aren't very many Wi-Fi 6 networks out there and not many Wi-Fi 6 clients.
Yeah, I think it's a good timing because, I believe a lot of companies are asking, themselves the question of should we upgrade to Wi-Fi 6 right now, right? And would I get any benefits from the technology if I upgrade right now? And should I do the investment? And all these questions. And, that's kind of like what they're trying to address from a technical standpoint in the document as well. They're talking about backward compatibility, how it would work with the current technologies, and how it would work in different environments, the enterprise space, and so on. So it's also, I think it's a good timing for them to put out those guidelines at that point, because they can answer those questions.
I agree, because when it comes to looking at IEEE and the standards they put out there, there's a lot of room for interpretation, which leads to confusion between different vendors. Look at all these proprietary configurations that we have when we deal with things like Cisco RRM or Aruba ARM, and then all the very specific tuning features that's within these vendors' configuration. And then you got your very specific high availability or redundancy settings that you must follow. So it's much more than design, because under the hood, you still got to work with the actual infrastructure to deliver a reliable service. The design is just part of it, because that's the first layer of connectivity. But I think there's a middle ground that we can come to, hopefully, because I know there's a set of guidelines that I follow when it comes to deploying wireless networks, my own set of best practices. So I kind of want to go into that as a discussion point between you and I, Francois, because we both do wireless deployments, we both do our own designs, and there's things that we come across in the field where you just kind of tuck that into your back pocket as like, okay, here's what I ran into in this environment. I just got to remember something like this just in case I run into it again.
Yeah. And talking about, guidelines. So I guess as an engineer, you'll get your own guidelines or things you like to do based on your experience, like you said. And then you're going to look at the vendor guidelines. Maybe you're going to look at the WBA guidelines. And there's also guidelines that comes from the WLAN Association, which is like a group of engineers just like you and I who came up together, tried to come up with some documents, guidelines as well. and they usually present at WLPC and then give updates on what they're working on. So we'll link the presentation that Peter McKenzie did this year at WLPC, where he talks about the update of WLA. So you can also follow what they're working on. You can become a member and then see those documents. So you can have guidelines coming from different directions, I guess, and then I guess with your experience, you can use it to do your deployment.
Yeah, probably handpick a couple of best practices from different documents, right? Because at this point, there's going to be a lot of different documents when we look at different companies that are publishing out these different associations, right? You got your Wi-Fi Alliance. They don't necessarily publish best practices, but they do create the certifications around these protocols. And then you've got the Wireless Broadband Alliance, which is a combination of Wi-Fi and cellular technologies. And then you have your WLA. There's just going to be so much out there, right?
Yeah, and then I think for me, like when it comes to best practices guidelines, I think the most important for the engineers is to understand what they're doing, right? If you just blindly follow what the best practice is and implement it without really understanding what you're doing, I think that's when it becomes dangerous, or not as useful as if you really understand what you're doing, right? So if the best practice is telling you to take a very concrete example, if the best practice is telling you don't use 80 megahertz wide channels or 160 megahertz wide channels, you kind of have to ask yourself the question, okay, why is the best practicing saying this before blindly implementing it, right? So I think that's the most important from the engineer standpoint, is to understand what you're doing.
Right. I think that's also a problem as engineers that we're running into is when you have network operators who may not be wireless experts, but are looking at these documents and they have good intention, right? They want to deploy a wireless network that's going to rock. It's going to be awesome. And so they may come across a document or something that says, use 80 megahertz wide channels because you'll get better throughput. And then that's just what they do, right? Or they take somebody else's best practice as the word, and it's just incorrect because of the environment they're in. Or things may change because when we go into 6 gigahertz, then maybe 80 megahertz and 160 megahertz is definitely going to be possible. So that's going to change the whole best practice. But I guess the next question is, why do we even need these best practices or these guidelines? And that's because the sheer amount of mobile growth that we're having, right? If we look at the Cisco VNI, they're predicting about 59% of traffic is going to be offloaded from cellular networks and onto Wi-Fi. And about 79% of that traffic is going to be video. And then you have things like future technologies, your VR, for example. I mean, I see a lot of applications trying to utilize VR. Yeah. And then we still have the growing number of IoT devices. So we're now seeing not just capacity, but the density of these applications, even the latency sensitive applications. And then we all have to make that user experience look good across our wireless networks. And so that's why we have organizations trying to create these best practices or these guidelines. So that way, when we do deploy X vendor's wireless network, it's going to be better than just sticking to the defaults. Right? You have to read it, like you said, Francois. You have to understand why you're looking at a best practice and implementing a best practice. Is it the best practice for your environment? But then that comes back to the question, if it's a best practice, why do I have to question it?
And then something else with Wi-Fi, specific to Wi-Fi 6 is, and that's what they are outlining in the WBA document, is they're saying that, right now, we're talking about 5G, 5G, 5G. It's going to answer all of our problems, but 5G is not ready yet.
Wait, right? I thought Wi-Fi 6 was going to fix all of our problems.
yeah, exactly. So that was my point, right? 5G is not ready yet. So, but in the meantime, we have Wi-Fi 6 that we can leverage to, handle all of these new IoTs, VR, autonomous vehicle, and they're actually projecting a growth of 47% of Wi-Fi traffic from now to 2023. So the Wi-Fi 6 technology is kind of ready. They're starting to deploy it, and so I guess we could leverage that. In the meantime, waiting for 5G to come, I guess, and even when 5G will come and be efficient, I don't think Wi-Fi will go anywhere. It will just be complementary to 5G in probably in indoor environments and in most enterprise environments.
Yeah, I think that's an important discussion point, because as we talk about these best practices and these recommendations, there's going to be these talks about Wi-Fi 6 versus 5G, right? Which one is going to win? Which one's going to be better than the other? And I don't think that's really the conversation we should be having, because Wi-Fi has been very dominant in the indoor space. And then when you leave the building, I pretty much rely on my cellular connection, right? So then I would be leveraging this 5G that's coming. Although we just don't, as a wireless person, from my perspective, I just don't know what the components are of 5G. Like what builds 5G? And I guess I need to look at some education, some presentations, but hopefully we can get somebody on this podcast to talk about 5G and what we really should be focusing on versus the marketing of Wi-Fi versus 5G. I don't think that's the right discussion point, but 5G will have their own set of best practices and guidelines, but that's probably dominated by these carriers. But we'll probably see the enterprise or private 5G. And so we'll see how that kind of plays out. I think then you'll see best practices on which one should you use, Wi-Fi 6 or 5G.
Yeah, maybe. Maybe it will come from the WB as well, since they deal with Wi-Fi and cellular. Right, so I don't know.
Yeah, and that's what we look forward to from an organization like that. But you still have to consider that these are companies that are trying to push, I guess, their agenda of these products. But at least they can come together to create a document we can read and kind of look at and go, okay, this kind of makes sense. But let's talk about these best practices that you and I use, because we didn't talk about this before. I don't think you and I have ever spoken about, hey, this is exactly how I design wireless networks. But I think we do have some common guidelines that we follow, because the first thing is we create a design based on requirements, right? That's a best practice for both of us. Is we don't design blindly. We try to determine what the use cases of the wireless network, like what kind of applications they're going to use, what's the traffic pattern, what types of devices are going to be used on this wireless network, and are there any constraints that I need to know about so I can design around that. Is that the same for you, Francois?
Yeah, exactly. Yeah, so the requirements, obviously they're very important, and the first step of every Wi-Fi design should be gathering all the requirements, because some of them will drive some of the design decisions you're going to make, right? So the obvious one will be where do you want coverage, what do you want to use the Wi-Fi for, what type of devices you're going to have. And then, like you say, you have a little less obvious ones, like, do you have any constraint, AP mounting locations, aesthetics, a traffic pattern. When I talk about traffic pattern, I'm talking about people moving around, right?
Yeah.
Maybe different densities, different moment of the day, and so you're gonna take all of this and then do your Wi-Fi design, and these requirements will sometimes they will limit your decisions, but sometimes they will help you taking the right decisions during the design. Designing Wi-Fi is never black and white. It's always taking decisions, right? And it's a matter of taking the right decision. And these requirements might help. These requirements, along with your technical knowledge, will help you to take the right decision for this specific design, I guess.
Yeah, and I think earlier when you were trying to talk about where people are going, that's more like foot traffic. What path are people taking? And that kind of relates to a previous episode we did about conference Wi-Fi, because if you're doing a conference, you want to know where people are going to be entering the facility from. Where are they going to be congregating when they enter the facility, right? So if you look at a conference, people are at a registration desk, or they're picking up their badges, and they're going to be using their mobile phones. When the conference opens up, people are going to kind of congregate, in the front, and then they'll spread out, right? So I think that's what you meant, like the foot traffic and
yes,
where
yes.
exactly they'll be walking around.
Did I say people traffic?
No, you said traffic patterns.
Okay.
Which traffic patterns can also be like the type of traffic that's going across the wireless network. Application traffic, I guess, would be a better word for that.
Yeah, no, I was referring to people moving around. Yeah, exactly.
Mobility of people. So I guess the next type of best practice, which is very common for all of us, the first thing that we think about is channel planning, right? You want to get the best amount of channel reuse in an environment, and then this is where you determine your channel widths, like how wide of a channel, or are you going to use something like dynamic bandwidth selection? Is that a best practice? I don't know too many people that actually use that feature, or dynamic bandwidth allocation, depending on which vendor you're using. Or maybe you're limited in the channel reuse. Maybe there's certain channels you can't use. So that's, again, like part of the constraints. And then leveraging what channels are actually supported by the devices. So this is why the whole gathering your device types is important, because why use an 80 megahertz channel width is if most of the devices on your network just support up to 40, for example, or maybe the application traffic is only utilizing like 20 megahertz of the 80 megahertz channel width. So there's things like that to consider, as well as the frequencies that are supported.
Yeah, and then the channel with 80 and 160, obviously if you use those channel bandwidth, like you said, you need to make sure that the client devices actually support them. And then because if the client device only supports 20 megahertz wide channels, you have these big 80 megahertz wide channels reserved for the communications between the OAP and the client, but the client is only using a 20 megahertz part of it, and then you now have 60 megahertz that you've lost that you could have used on other AP, and you could have leveraged that capacity somewhere else, a spectrum somewhere else, that you're actually losing. And plus you have less channels available to you if you use 80 or 160, and then you start to reuse those channels more often, and then bringing these APs closer to one another, generating co-channel interference. So the document is talking about Wi-Fi 6 and saying that most likely we still won't leverage 80 and 160 megahertz wide channels in the 5 gigahertz band, at least with Wi-Fi 6, because we kind of have the same limitations as what we talked about. However, with Wi-Fi 6, there's something that's very interesting, something new that's coming, and it's called preamble puncturing.
Yes.
And
this I think is really interesting, but only with Wi-Fi 6. And I don't think it's a requirement. It's an optional feature. So that's another thing to consider.
Yeah, it's defined as an option capability in the 802.11ax draft. So who knows who's going to implement it. But the idea behind the preamble puncturing is actually quite interesting.
Yeah, and this is an improvement over the previous wireless generations, because if you've got a 40, 80, or 160 megahertz wide channel, and let's say there's interference on one of those channels that comprises the bonded channel, then basically it just reduces itself. It reduces the whole channel, and it won't utilize the full 80, for example.
Yeah.
And with Wi-Fi 6, we see this improvement with the preamble puncturing. I don't know if you want to go into that, Francois. Briefly.
So it allow a larger bonded channel to withstand the interference on a single 20 megahertz wide channels. Within its bound by simply puncturing the larger channel width and removing that 20 megahertz channel from the transmission. So if let's say you have 80 megahertz wide channels and you notice you have interference on one of the 20 megahertz wide channel, you can just decide to not use that 20 megahertz portion of your overall bonded channel and puncture pretty much the transmission, so you don't impact your transmission and you don't generate interference for the other Wi-Fi network operating on the 20 megahertz wide channel.
Right. So if we take the example, and this is an example from Aerohive, David Coleman's blog post on this. If you take channel 58, it's a 80 megahertz wide channel. It's channel bonding channel 52, 56, 60, and 64. Right. Previously, if you have interference on, say, channel 56, your primary, let's say your primary channel is 52. If you have interference on channel 56, the puncturing means they would just remove channel 56 from that 80 megahertz channel width, but you can still use the 80 megahertz, just not that 20 megahertz wide channel 56 portion. So you can just hop on the other three channels and still have that bonded. So I think it's a very interesting feature that I want to see if it gets actually implemented on devices and APs.
And it would allow us to do dynamic bandwidth operation more often. That's what the document is saying. And also new functions like BSS coloring and the new spatial reuse can also allow us to do those dynamic bandwidths a little bit more often. The only challenge with BSS coloring and the way we do the new spatial reuse with Wi-Fi 6 is, how would that work with legacy clients and standards cohabiting on the same space?
Yes. So we can talk about that in a couple of bullet points when we just kind of talk about Wi-Fi 6. But let's move on to transmit power, because transmit power is another feature that gets tuned quite a lot in environments. And we base this transmit power on our design, right? On our how we want the transmit power configured on each access point or radio. And then a lot of us also utilize something like RRM to dynamically configure that transmit power, or use a range, because you don't want to exceed your regulatory constraint there. But when it comes to transmit power, for me, I tend to try to match it towards the client's max transmit power. I don't know if you do the same, Francois. Do you?
Yeah, I try to do that. And I also give myself a little margin, because usually the client devices, they will advertise their maximum transmit power, but it doesn't mean they always use their maximum transmit power, right? Sometimes to preserve battery lives, they would go a little lower if they can. So I try to look at those maximum transmit power that the clients will be using, and maybe I cut it in half and I use that for my baseline transmit power. And therefore, I also have like a little margin. If on some access points I need to increase the transmit power a little bit, it gives me a little bit of flexibility in adjusting the transmit power as well in my design. So yeah, that's kind of like how I do it. The only time I am even more cautious as well is when you use external antennas with high gain. You don't want to exceed, like you say, you don't want to exceed your regulatory domain. So you have to be very careful in calculating your RP, make sure everything is going to be fine with the transmit power that you define.
Yeah, and I think transmit power, the environments I run into always have it set to auto within the system itself, and usually it's a large range. It's like 0 to the max, and they tend to not modify that value because usually they don't do a design. And so tuning the power is usually an easy way to try to mitigate an immediate issue, because I'll see like dense AP deployments, and then the transmit power on each one is really high. So you get that sticky client issue, or a lot of channel overlap, because APs can just hear each other from across the office space. But this is, for me, like another best practice, which is tuning the transmit power per the design that you've created.
Yeah, that's good.
I don't think we need to beat that one up so much. The one thing I don't hear a lot of people talking about are the actual device capability, especially when I talk to other organizations and ask them, all right, you've got your wireless network. What kind of devices are, like, what are their capabilities that you're adding here? Like these scanners, for example, in a warehouse environment. And usually they're like, well, it supports 2.4 and 5, and that's all they would really know, right? And so they don't know if their devices support mobility, for example, such as 802.11r, or even the other amendments, KV. So I always look into that, because if roaming is critical, those are some protocols I'll want to leverage in the environment. But typically I'd like to look at which devices on the wireless network are most critical to the organization, and how can we get those to work more efficiently over the wireless network that they have. Do you look into devices quite a bit, Francois? And I know it's harder for environments that are BYOD.
Yeah, so I try to look at the different client devices that the client will have to support on its specific environment, and based on these devices, you try to find which one is the most critical for the business, and also the least capable in terms of Wi-Fi capabilities. That's why we usually refer to the LCMI, least capable, most important device. And then what I try to look in terms of Wi-Fi capabilities, what I try to look at is, what type of data rate can they support? What type of Wi-Fi version do they support? Is it 802.11n, AC, AX, I guess? Yeah, and then after I've done the basics on trying to find out what they support, what type of data rate, what type of channel width they support, I try to look at the more advanced Wi-Fi capabilities, such as does it support 11R, 11V, 11K, and then I try to see if I can leverage these capabilities in my network. The only thing you have to be very careful when you do that, when you try to leverage those advanced capabilities, is make sure that it's going to work well with the other devices as well, right? Because sometimes, configuring some of these capabilities might break the network for other devices. So you kind of have to do your testing, your homework, or work on different, working on different SSIDs to make it work the way you want it to work.
Yeah. And I think with enterprises, it becomes a best practice to standardize on a device that has these certain capabilities, because then it's easier to support. And like you said, you can tune the wireless environment to those devices. But then the challenge comes across with BYOD and not knowing what those devices are. So you, like you said, with the least capable client, then your best practice is to support as many devices as you can.
Yeah, and then for BYOD, what I do is, if I have like no idea what's going to be, what type of client devices will be in the environment, what I do is I try to establish like a client mix. So I would say, in my environment, I'm gonna expect to have, 50% of, two-stream device, 11 AC two-stream device. I'm gonna have, maybe 10% of 2.4 only and two-stream device. So I try to establish this client mix that would fit the environment, and I just base my design on it. So I base my especially my capacity planning on it, and that could change depending on your environment, right? So what I always advise is, try to see if you already have a network with a network monitoring system, and you can already establish the client mix that you have currently connected in your environment. You can just start there and see how it could evolve and how it will evolve for the next couple of years, and then use that client mix for your capacity planning.
Yeah, exactly. If you have a network management system that can tell you what type of clients are connecting to your network, you can get a good understanding of, okay, here I don't have 802.11n devices anymore, so let me tune my network to support the later devices, and then that really sets the stage for determining those client types. And this reminds me of Cisco Live, Francois, when we went to see the behind the scenes and how they were monitoring the network, and you were able to see those client device types, and you could see such a huge number of 11AC devices versus like the 11N. There was very few of those, but there was a very large number of the latest type of devices.
Yeah, in this type of environment, very high density environment where it's just like pretty much public Wi-Fi. It's gonna be like convention centers, stadium, and environment like these. That people are gonna come in with their phones, and then people usually renew their phones every 2-3 years, right? So that's why you see most of the devices as 11AC devices, right? But for example, in your environment, in like a university or in a school, people or students or staff might not be renewing the equipment that fast. So you might still have to support, like you might not have, the same ratio in terms of, 11 AC devices versus the rest.
Exactly.
But yeah.
So now we've come across like all these topics that we talked about when it comes to design and gathering requirements. I'd like to move on to talking like best practices for deployment, because the deployment is just as important with the design. How these APs get installed, how you align antennas, for example. I've seen a lot of environments where there's just too many APs, right? And people say, oh, we have a coverage issue, let's just add another AP, without really looking into what the problem may really be. Because one of the things I look at is, all right, you don't want to install these APs way too close to each other, because there's too many issues that could happen when they are too close, especially if you're using omnidirectional, the built-in internal omnidirectional antenna. I find that's like one thing I like to avoid, is the proximity of how these APs are installed. Yeah,
so I think when we talk about deployment, I think there are two problems in the field. It's first, the way us engineer design and place the APs on our design, and second, the way we transfer that information to the installer so they can do the work, right? Sometimes, so let's talk about the first part, and exactly what you were talking about. Try not to place the AP too close to one another. What could happen if you place the AP too close to one another is that you could have it could impact the coverage pattern of the antenna, right? So you might not get what you designed for in your predictive model tool. And that could and you could also create interference if they're on a adjacent channel. So and that could impact the Wi-Fi performance. Yeah. Same if you place the AP too close to like a metal reflecting surface, that could impact the
propagation of the signal.
The coverage pattern of your antenna. So if you thought you had a patch or an Omni, and then you end up with something different that will impact your design, your interference, and everything else, that might not be the best way to do things.
Yeah, and I find that installing some APs too close to each other, adjacent channel interference, to me is one of the worst kind of interference. It's far worse than co-channel interference, because with adjacent channel interference, that if those APs are really close, the signal can really overlap on the other adjacent channel, for example, and cause like really bad interference there, where you might have a lot of retries.
Yeah, so adjacent channel interference is really an interference, meaning like the two APs don't really understand each other. They just step on top of each other.
Right.
And then, co-channel interference, it's not really an interference, since they can understand each other, and they can make sure that they don't talk at the same time.
Yeah, that's why I like
right?
calling that one co-channel contention.
Yeah, exactly. Some people call it co-channel contention for that reason. Yeah, co-channel interference, I guess, if you want to be exact, would be, an interference that you have on the same channel that doesn't understand Wi-Fi, I guess, and will talk on top of Wi-Fi access point.
Yeah, something operating on the same channel, but the Wi-Fi devices cannot demodulate that signal for whatever reason.
Yeah,
and the other thing I look at with the proximity of APs is the way devices select the access point to join, right? So maybe you do not intend them to join, like in your design, you don't want certain devices to join an AP, or you're trying to prevent them from joining an AP, which is pretty difficult. But when they're really close to each other, it's hard to determine like which one a client will join to, and then maybe you get some sort of sticky client situations as they try to move around the floor plan, for example. And I see a lot of that where people say, well, I'm really close to this AP, but I'm not, the device is not joining it. They're still joined to the other AP, which could be a couple of different reasons, right? One is the proximity of the APs. They're really close. So that means the signal is still strong enough for the other device to not move or associate to another AP, or either the transmit power is just way too high, right?
Yeah, so the placement of the EP will be important for first the the RF design, I guess, and then second, like you said, for how the clients will behave on your Wi-Fi network. So that's two important points. You're right. If you want to know more about the client devices and how they'll behave, you can watch the presentation from Jerome Henry. He does a lot of these presentation at Cisco Live. You can watch those presentations online and try to get a little bit more data on that. It's very interesting.
Yeah. So,
also, what you could do is you could use external antenna.
Exactly.
To help focus the RF where you want, to help contain the signal. If you need a high density environment and you want to be able to reuse your channels often. And the external antenna could also be used in other scenarios where, for instance, you want to hide the access point, or the customer wants you to hide the access point, but you still want to provide good RF coverage. So the external antenna I see it as a great tool in our toolkit to meet some of our requirements.
Yeah, for me, I use external antennas as much as I can. Now, it does add some extra cost to the overall project, but the end result is a better experience for the devices. You actually shape a signal towards the device. You can get a better SNR because of that, and also with trying to follow aesthetics for the environment, you can get really flexible with the antenna selection and how that can blend in with the environment. Because I work with environments where aesthetics is really high on the list, And so we have to get creative with external antennas, since nobody wants us to hang these APs on the ceiling, because maybe that's not even possible. Or we use special antennas that go into the walls, and it's just a plate. It's a special antenna from Ventev, and you could actually the junction box antenna, and you could angle the antenna within the junction box. We've used that very successfully to accommodate some of the aesthetics. And so when it comes to like best practices of delivering good signal or guidelines, I like to use the external antennas as much as possible, especially in like lecture hall environments where you, like you said earlier, the high density, and I need to get that channel reuse because I have to accommodate the capacity in that room. I try to use those external antennas as much as possible and really create these separate cells, so that way we have different contention domains.
Yeah, it's a really the external antennas is a really good tool for us to use and help us, design better RF. The next thing we want to talk about is avoiding hallway only installation. So the way I like to rephrase this one would be to say that, use your walls in your advantage to contain the signal, and place the APs where the clients are. So I think the way we presented it with the avoiding hallway only installation is good. You don't want to put all the access points in the hallway. If you can avoid that, that would be better, because you can minimize the interference you bring here on the floor, and you can also place the AP closer to the clients, meaning increasing the SNR you're providing to your clients, meaning allowing them to use their maximum data rate. So what you can do is you can try to place the APs where the client are, and then use the wall in your advantage to contain the signal. So if you can place the AP in a room, and that will allow you to use the walls to contain the signal and reduce the footprint of that AP, and then reduce your CCI overall. Try to leverage those as much as you can.
Yeah. And I feel the same way. I have an environment where, prior to me being on there, somebody deployed all the APs down a hallway. I would say maybe like 15, 20 APs. And they didn't, the reason why I say don't put them in the hallways is because nobody is actually sitting in the hallway doing work. They're in the rooms. And so if we can move those APs to the rooms, like you said, better SNR, better RSSI, right? And just overall better signal, better overall, like the quality of that signal is what the device gets. Now, some of the things to consider when you're doing a hallway only is if you're using things like RRM, that's really going to negatively impact the environment, because all the APs can hear each other at such a loud signal. And so what they end up doing is bringing the power down, because they go, oh, well, I have all these APs really close, so I should turn my power down. And then that creates coverage gaps in your environment. So if you can avoid hallway only installations, please put them in, like in your design, work with putting them in the rooms. I know it's not always a possibility, so you always have to work best with what you have. And I always remember this from Jake Snyder, who says signal is better than no signal, right? So you do want to at least get a signal in your environment the best you could in a design. And you could simulate like a hallway design and see what that looks like. But sometimes people forget, when they're using these RRM algorithms, that hallway design could really create a bad user experience.
Yeah, and this doesn't mean that you never place access point in the hallways. If you need the Wi-Fi in the hallway, you might need an access point there. And what you could also do with hallways is, and actually they talk about that in the white paper, you can actually leverage directional antennas. So let's say you place APs in the rooms to cover your rooms, and then you need coverage down the hallway. You could use a directional antenna to cover the hallway. So when someone goes out of the room into the hallway, they will roam to the access point, in the hallway, and then if they walk down the hallway, they'll stay associated to that access point, and that would provide a better experience as well.
You still got to facilitate roaming somehow. So yeah, having an AP in the hallway is still important for roaming purposes, but just don't put all your APs in the hallway.
Yeah.
And so that really drives to the point in deployment is doing a post-deployment survey or validating the physical installation as well when it comes to the post-deployment. And these post-deployment surveys is going to identify things like any deviations from your design. So if you have your design there and you're doing the survey, you can see, okay, what's so different from the design? Like how far off am I from the design? And how far off are the AP installations, for example, right? And that way you can go back to the installer and say, hey, I have an AP that's supposed to be here. I don't see it. But there's one over here. Can we move it to where I originally planned? Things like that. And I come across that every once in a while. I mean, it's going to happen because you're not the one physically doing the install, right? And so the installers have to interpret your instructions. And I know, Francois, you create really detailed instructions for installers.
Yeah, because I guess for my case, it's different from your case because you usually always work with the same people, so they kind of understand how you want things to be done. For me, depending on the customer, I might not know who will be, pulling the cable and physically installing the APs, the antennas. So what I like to do is I like to create, like you said, a very detailed installation document. So I minimize the number of issues we could have when we come back and validate the AP installation, right? And you also minimize the cost of everything, right? You don't want the customer to bring the guys back to, move access points and adjust how the AP was installed, because it's just going to waste everyone times and money. So yeah, like you said, I like to detail everything. I used to not do that. And then after one day I did a visit with one of the installer, and I was just talking with them and trying to better understand their job. And when I went back home, I tried to do the job myself.
Try to make it easy for everyone.
I went to the hardware store trying to figure out what I would need. And then I was like, man, this is not obvious. So from that day, I was like, okay, I'm just going to give them a little bit more detail. I'm give them everything that I would like to see. And then when you do that, something amazing happened too. It's because the installers see that you're taking care of them. They give it back to you, right? So they're more willing and installing everything properly, not cutting corners. And then when you come back and then talk to them and to do a little change, they're willing to help you out because you helped them out at the beginning.
Yeah, there's just a lot of room for error when you're handing over instructions to somebody else to do the installation, especially if they're not trained in how, at least some of how the basics of wireless works. And then you have especially antennas that need to be installed. They might not necessarily know that an antenna means directional, like an external antenna means directional signal if it's a patch antenna. And so I've seen installers just kind of pick where an antenna, like how it's angled. And a lot of times the diagrams that we provide, right, the floor plans that show where the APs are, they don't know like how high it's supposed to be mounted or what direction it's supposed to be facing. So a lot of detail has to go in with the assumption that they don't know what you really mean. You should really give them clear instruction and maybe diagrams in your installation guideline of how that should be done. So that way with these best practices, it's not just technical best practices, but also, working with other people, best practice of communication, clear communication lines.
Exactly. I'm all for that,
So
right.
I think it's interesting that now we're going to talk about what best practices could be with Wi-Fi 6. And this is a challenge because Wi-Fi 6 is not completely rolled out anywhere.
Yeah, I think, and Wi-Fi, the challenge with Wi-Fi 6 is you could be using it for different requirements, like we said earlier in the episode. So you could use it for IoT, where you don't need high data rates, but it's more like a low power, low data rate, big coverage type of deployment. Or you could use it for VR, where it's more like a high throughput, low latency type of network. So I guess the requirement piece would be even more important.
Yeah, so we want to preface this with it's too early to tell what the best practices will be with Wi-Fi 6 because there's so many different features that we need to take into consideration. And the first one for me is resource units, because how a vendor will implement the use of resource units could vary across vendors, right? There could be APs that support specific number of resource units. So what I could see is a lower end AP may not have many resource units to use across many clients, but maybe like a flagship AP might have the maximum amount of resource units identified in the 802.11ax draft. So that's something to consider if you're deploying like in high density environments. And I know some clients try to meet certain budget requirements, right? And they'll go, well, this is a Wi-Fi 6 AP. It's a lot cheaper than the higher end Wi-Fi 6 AP. So why don't I go with that one? But if you're deploying in a high density environment and maybe the resource units can be very important for that environment, then that's something to consider.
Yeah, a lot of new features, we talked about it on the show before, but a lot of new features will impact a high density network in a good way. All right, OFDMA, 1024 QAM, 8 spatial streams. I don't know if that's going to happen, but anyway, uplink, multi-user Mimo, these type of things that are outlined in the white paper, they're going to help us with high density environment, but we need to know how it's implemented, like you said, like OFDMA and resource units. Like you said, we don't really know yet when exactly it's used. Is it used right off the bat, or is it used if the AP detects that it has multiple Wi-Fi 6 devices supporting OFDMA, or is it used when the channel utilization goes up the roof? So all these little things, I guess you have to study and find out for your specific vendor to try to see how you could leverage that and how it's going to impact your, your deployment.
Yeah, and the same thing goes with target wake time. How is that going to be implemented? And the scheduling piece, like when we try to standardize on how some of this technology works in your environment, it's kind of hard to really look at the data sheets and tell, all right, this is how this vendor implements target wake time, TWT. And so maybe TWT is very important in your environment, maybe because you have a lot of IoT devices and that's more critical in your environment. But the best practice would be try to find that vendor or feature, and maybe it's something that can be configured on the back end side of things, but we still just don't know yet with some of these vendors.
So what we can say is, in the draft, a lot of features are really nice, really are promising, and TWT, target waiting time, is one of them. OFDM, the one we talked about as well. Also, there's one in the white paper, they're talking about band steering a little bit as well. And then talking about Wi-Fi Alliance certification program called Wi-Fi Agile Multiband, which will be a requirement for Wi-Fi 6. And if you look at the Wi-Fi Agile Multiband certification, maybe we can do a deep dive one day, because it's a pretty big document. But if you take a look at it, it's talking about supporting fast roaming, 11R over the air for better roaming, supporting 11V BSS transition. So leveraging some of these advanced Wi-Fi amendment, I would say, to provide a better user experience, to provide better roaming in between your Wi-Fi bands, but also between Wi-Fi and cellular. and Wi-Fi 6 will take advantage of that because it will become a requirement for Wi-Fi 6, right? So I think this is a big step in the right direction, because nowadays we have a lot of issues where client devices don't support those features, and we cannot fully leverage them on the infrastructure sides. But if the Wi-Fi Alliance says, okay, Wi-Fi agile multiband would be a requirement for Wi-Fi 6, this will help us a little bit.
Yeah, and when we talk about all these features, what about the best practices when it comes to designing for Wi-Fi 6? A lot of that still isn't implemented in the software that we use, right? So one of the things that the Wireless Broadband Alliance, the WBA, outlines in their Wi-Fi 6 deployment document, they talk about needing tools to include the effects of BSS color to co-channel interference or co-channel contention. And that's very important because that changes how we look at co-channel contention. Because with BSS color, it's supposed to make that a little bit more efficient for APs sharing the same channel. But the thing is, these vendors that design the tools, like Ekahau, for example, they need to understand how the vendors implement BSS color before they even include that into their design application.
That's going to be a challenge because now, doing a thorough capacity planning for AX will be quite complex now.
Yeah, just imagine all the math that goes into that, right? Depending on how many BSS colors are going to be used and how many BSS colors are supported per vendor, for example.
Yeah, and not only BSS coloring, but OFDMA, and all of these features. And I'm not even sure the vendors will be willing to disclose everything. You know what I mean?
And I mean, that's something that probably Ekahau needs to work closely with these vendors, have that close relationship, because it's important for the design. We need to know, okay, does this change my capacity? Do I need that many Wi-Fi 6 APs with this high density environment if I'm going to be leveraging OFDMA and BSS color, for example? Like, how does that affect the actual design and the number of APs I need for my environment?
Yeah, so it's going to be quite challenging. I'm not too sure how they're going to do it. I'm not sure if they're going to have I'm not sure if they're going to go and see every vendor to have a very thorough solution, or try to have a solution that's going to bring you close to the solution, close enough to the solution.
And will we see what that is within Ekahau, for example, right? Like, can we see how many BSS colors are supported on an AP, or how OFDMA is used within the design or simulated within the design, right? So there's a lot of unknowns.
That would be awesome. Yeah, and also if the vendors could tell us, that would be nice.
Yeah, good luck.
So we don't have to do a packet capture to find out.
So there's not too much we can talk about best practices with designing Wi-Fi 6 other than that needs to be developed, and there's a lot of information that needs to be analyzed in order to create the support within the design applications. But what we can talk about is possibly how this works with the coexistence of Wi-Fi 6 and previous wireless protocols, because the backwards compatibility is going to be there, right? We're going to have this transition period. And so a lot of people, I think the question that I see the most is, will having Wi-Fi 6 APs create a better experience for Wi-Fi 5 clients or older? Yeah, yes. I think so too.
Well, if you're only talking about the the technical behind it, so because Wi-Fi 6 or 11x or high efficiency will make those Wi-Fi 6 communication more efficient. So pretty much we're saying that we're going to use less spectrum for those Wi-Fi 6 communications. Then now you have more spectrum available for the rest of the legacy clients. So essentially you're giving them a little bit more bandwidth. So you're potentially increasing their experience.
Yeah. So as long as you have, more Wi-Fi 6. This is when we have actually more Wi-Fi 6 clients. Is when we'll actually see maybe the coexistence and backwards compatibility performance increase because, like what we talked about earlier, the OFDMA and BSS color, because of the scheduling and the handling of communications for Wi-Fi 6 is now more done so on the AP. Those transmissions for Wi-Fi 6 can be done within a single transmit opportunity for multiple clients. And because of that, you increase the airtime for the older clients, right? There's more airtime for them to use because now we've been more efficient with Wi-Fi 6, assuming that the way we interpret the amendment will work the way it's supposed to. And that's where we can see that performance increase with the older protocols because of that transmit opportunity in OFDMA. But also, even if we don't have that many wireless clients with Wi-Fi 6 yet, you're still installing Wi-Fi 6 APs with better hardware, right? So you should be getting at least some performance there with your older clients.
Yeah, maybe that would be minimum, except if you have a high density of environment. But I would say that minimum. And also, when we say that we're giving more airtime to the legacy clients, that's true. So that's how we will improve their environment, but still they won't be supporting the new AX features or the new OFDMA and all of that.
One thing that the Wireless Broadband Alliance outlined in their Wi-Fi 6 deployment document was if you have older clients in your environment, like 802.11n clients or even older, they actually say disable Mimo within the configuration.
Yeah. And they said to use 20 megahertz wide channel as well.
Yeah, so there are so we could look at that as a best practice because of the legacy devices and how they work, right? Mimo won't be advantageous to those clients because they don't even support it, and they were designed with, or those older clients work better with 20 megahertz wide channels.
That's interesting because they are talking a lot about multi-user MIMO in their document. So yeah, you're right. They're saying they're recommending it to, disable it if you have legacy client. But even if you have, AC multi-user MIMO compatible client, if they're not predominant on the Wi-Fi, you should disable it because they generate a lot of sounding frame and overhead.
Yeah,
they're saying the only time where a multi-user MIMO should be implemented is in a low client density, high bandwidth environment where large packets are transmitted. So, yeah, I really don't know multi-user MIMO. I'm not a big fan of it because it only works in these type of environments. Stationary clients, low client density, high bandwidth type of deployment, but the Wireless Broadband Alliance and these guys that work for those alliances or even the IEEE, they seems to love the technology and push it a lot. So I'm not sure if it has potential. I'm not sure yet, but they really want to make the 8 stream work. They really want to make the multi-user MIMO work with Wi-Fi 6. So I'm looking forward to see how it's going to work in the real life, if it's really going to be useful for us in the real life.
I agree. It's hard for me to really see it in action. And I think we need...
But if so many smart people are pushing it, I'm trying to be like, it might be a reason behind that, no?
Who knows? I can't validate it. That's the problem I have. I have a hard time validating it, and neither have I really tried that hard to validate it.
Yeah, we don't have a lot of multi-user MIMO devices now, but if all the new Wi-Fi 6 devices come up and support it, we might be more successful in implementing it. And then you have another question: is how does multi-user MIMO works with multi-user OFDMA? Like that's going to be quite complex.
It is. There's going to be a lot to really unpack here. in the next couple months, maybe the next couple years too. But I mean, when we talk about best practices, it's not usually a best practice to hop onto the next and latest and greatest because of things that need to be ironed out with like issues, for example, or drivers of these clients. So that's one thing to consider. But as we talk about developing best practices or guidelines, I mean, we talked about a lot of things like design based on requirements. We talked about channel planning and transmit power, taking device capabilities into consideration, and how these access points are deployed in your environment. And then I think we touched upon the Wi-Fi 6 best practices, what we think will be some best practices, but also some of these best practices are going to be really developed later because of the lack of tools and resources to create a best practice, right? I don't know anyone who's deployed a large Wi-Fi 6 environment with a bunch of Samsung S10s, except for Cisco and their test lab.
Yeah, it's not very popular yet. And also without the lack of visibility on how Wi-Fi 6 is implemented on each vendors, and which features are available to us today, that's really harder to know exactly the best practices for Wi-Fi 6. But I would say if you're asking yourself some questions right now, if you're at a point where you're not too sure if you want to move to Wi-Fi 6, you should give the document a read. We'll link it in the show notes, but you should read the document from the WBA because it's a technical document. They explain, how the new features of Wi-Fi 6 should or should not improve our our networks. Right? You can go to the section that's called Wireless Enterprise Network, and they answer those questions for you. And they answer if you pretty much after the read, you should know if you're ready or not.
And I think it's definitely a good read. It does require like a sign up with an email address to download the document, but it's worth downloading. And so we want to ask you guys: do you follow any wireless best practices? Do you have your own? We want to hear what you guys have to say. Let us know in the comments. Go to cleartosend.net/178, where we'll also have a link to some of these resources. And we look forward to creating some discussion there and knowing what best practices you follow. And hopefully there's something that maybe we were able to provide to you as well. So thank you guys, and we'll see you in the next episode.
Thank you guys. Have a good week. Bye-bye.